welcome to yet another episode of a practice problem in kinematics, and this problem is going to be a little bit more involved, and yeah, the problem is a little bit long because I want to cover a lot of concepts over here. So pause this video and just go through the whole problem. I don't want to read this out. Okay, let's try and solve this. The first step is definitely going to be drawing this particular situation. Alright, let's see. I'm gonna make the small drawing over here. Alright, so here's a solution. Solution comes here. And here's my attempt to the solution. I'm gonna try and draw this guy. So he travels north at a uniform speed of 10 kilometers per hour for 2 hours. So I'm going to assume this here is going to be his initial position. Alright, and it's important to label that. I always love to label so I know from where to do my calculations for average values. So this is the initial point, and then he travels up, that's north, let's call this as north, and I'm going to assume north as my positive, so south is going to be my negative, because velocity is sign sensitive, remember that. You're free to choose that, by the way. I'm going to call that as positive. He travels for 2 hours at 10 kilometers per hour, therefore he's going to end up somewhere over here. Let me call it as point B. Okay, so how much distance do you think he traveled? We can do this mentally. We need to do this mentally. Okay, he travels at 10 kilometers per hour for 2 hours. Speed is distance by time. Distance is speed into time. But you know what I like to do when I'm doing this mentally? See, I need distance, so I need kilometers. This kilometers per hour, you multiply it by hours cancel, and you get the kilometers. That's how I like to do it. Alright, so 10 kilometers per hour into 2 hours, so you get 20. Therefore, he ends up traveling from here to here. This distance is going to be 20. Let me write that. I'm just gonna mark it over here somewhere. Okay, so this is 20. It's in kilometers. Then he immediately turns around and travels south uniformly, again, nice uniform motion, at 25 kilometers per hour for 1 hour. So I'm gonna draw that here. He actually goes back, but I don't want to spoil this diagram. So do I have? No, I can just draw it over here. So let me draw it back. So he travels back this way now, and he travels for 1 hour. Again, let's see how much distance he travels. 25 kilometers per hour for 1 hour. That means it's 25 kilometers. So he travels 25 kilometers this way. He already traveled 20, so he comes back to the initial position, and then he travels an additional 5 and ends up somewhere over here. Let me call that as point C. So he goes this way, then returns back, and he goes further back. And this is 5. I hope you can see that. Okay? And we need to keep track of time as well. So let me call this as time t equal to 0. So this is t equal to 0. Then this would be t equal to 2. It's in hours, remember. And this would be t equal to 3. This is the situation. So imagine the animation, it goes like this, and it goes zoom this way. After that, I don't care what it does. Alright, let's look at the questions. We need to calculate Bob's average speed and average velocity for first 2 hours. Let's do that. Okay, first 2 hours. So this is first part, first section. In the first 2 hours, average speed, well, that's easy. That's going to be distance by time. He travels 20 kilometers. Divided by time, he takes 2 hours. As you can see over here, that's 10 kilometers per hour. Well, that's easy, no biggie. But we need to also calculate the average velocity. Now, average velocity is displacement by time. And you would immediately see we need an axis for this. But you know what? We can do this even without axis if we are careful about displacements. Alright? So we're gonna assume, okay, we don't need axis. Forget about origin and everything. Alright? So let's just think about what's his displacement for the first 2 hours, where he was over here initially, and then he came over here. So his displacement is 20 along the positive direction. Can you see that? If you do final minus initial, you get a positive 20. Or I just like to see he moved this way, so his displacement is this way, and this is positive because I chose that as positive. So his displacement is plus 20 The time he took is 2, so he gets a plus 10 kilometers per hour. But remember, our final answer should not have plus and minus because that's our chosen. So we should answer this using north and south. So I would say the answer is 10 kilometers per hour north. Remember, even though they did not ask me exclusively for direction, velocity is sign sensitive. So it's understood. Whenever they ask you for a quantity which is sign sensitive, you have to give the answer with the sign. And here, the direction represents the sign. Okay, let's now consider section 2 of the first part. We need to calculate the average values for the last 2 hours. Last 2 hours. What does that mean? Well, we know at t equal to 0, t equal to 2. So this is first 2 hours, and then this is last 1 hour. Oh, I need to calculate for the last 2 hours. That means I need to divide this into 1 hour section. So let me ask myself, where was he after the first hour? Well, he's traveling at 10 kilometers per hour. After 1 hour, he's at 10 kilometers. So let me put one more point there. We need that for the second part. One more point. And please concentrate. A, B, C, let me call it as D. So this is 10, and this is also 10. I hope you can see what's going on. And this is t equal to 1. So I repeat, time t equal to 0, he's here. Time t equal to 1, he's here, traveled. Time t equal to 2 hours, he's here. Time t equal to 3 hours, is here. That's what's going on. That's right, because he's traveling very fast in the last 1 hour. Okay, so the second case, we need to calculate the average speed for last 2 hours. Let's do that. What is the distance traveled for the last 2 hours? Pause the video and try to figure this out yourself. Hope you did that. My turn. Okay. What is the distance traveled? Let's see. I have to calculate the distance traveled from here to here. Oh, I forgot to write down the points. I'm doing the physics from D to C. You see that? From here to here. So he first goes 10. So let me write that. It's 10 from here to here. Then he goes 25. So 10 plus 25. Divided by, what's the time span? Well, that's 2. So that's 35 divided by 2. That is 17.5. Right? Kilometers per hour. What's the average velocity? It's displacement by time. We need to be careful now. Displacement from here to here, how much is that? We can put axes and put positions, but let's do it directly. See, he travels this way, so the displacement is represented. Let me use pink color for that. Can you see? The displacement is from D to C. I want this displacement from D to C. That's 10 plus 5, that's 15. But that's minus 15. That's important because this is positive X or positive direction. So I'm going downwards. I'm not moving downwards. His change in position is downwards. So that's minus, what was that? 15. Divided by 2, that's minus 7.5 kilometers per hour. Whew. Okay. Third one. The third one is for last 3 hours. The last 3 hours means, where am I doing the physics? Oh, not last 3 hours, for the entire 3 hours. Yeah. That means I'm doing the physics from A to C. A to C. Okay, one last time. What is his average speed? Well, now it's the total distance that he traveled, and that's easy. His distance traveled from A to B is 20. Then we'll do B to C, that's 25. So 20 plus 25 is 55. And we divide by the total time, that is 3. Time to use my calculator for this. You guys should do it mentally or do it without a calculator, but I will just do 55 divided by 3. That's 18.33. 18.3 kilometer per hour. That's the average speed. Okay, one last thing. What is the average velocity? What's the displacement from 0 to 3? That's what I want, right? 0 to 3, A to C, yeah. So I have to now look at this. Should I draw that? Okay, I'm gonna draw that this way. From here to here. And that's 5 kilometers. I hope you can see that. Again, it's negative. So that's minus 5 divided by 3. That's the time span, 3. 5 divided by 3, that's minus 1.67 kilometers per hour. Ta-da! We have solved our problems. Oh, that's the first part. We've solved the first part. Let's now do the second part of the problem. Can I flip it over? No. The second part of the problem involves drawing graphs.